We now look at some examples. So if you have a 250 kilogram load that's attached on a wire of length 3 meters, the cross-sectional area of the wire is given, Young's modulus is given, what is the increase in length? So it's like we have a support here, a wire, and then we attach a weight that has a mass of 250 kilograms. The length of the wire is 3 meters, and the wire's cross-sectional area, so the wire is like this, the cross-sectional area is 1 square millimeter, and we want to find by how much it stretches. So it's going to pull down and become longer. So what is this delta L? So we go to our equation, F over A, the stress, equals Young's modulus times the delta L over L initial, the strain. And here we are looking for the increase in length, so the delta L is what we are trying to find, and delta L will now be F over A and Li over Y. Now the force is due to the weight, so that's 250 kilograms, and you need to multiply this by 9.8 meters per second square. That makes it newtons. The area is 1 millimeter square, so 1 millimeter square, multiply that with 10 to the power minus 6 to convert it into a meter square, and the initial length is 3 meters, and the Young's modulus is 8 into 10 to the power 10 newtons per meter square. So this becomes Newton, so the Newton will cancel with the Newton, and the meter square will cancel with the meter square, and we're left with the meter. And when we solve this, it comes out to 0.09187 meter, which can be written as 9.19 centimeter. The 3 figures. So this 3 meters will become almost 3.1 meters. Now, the second one, a crane has a cable made of steel. The length is now 100 meters, and we have a weight to be lifted. The crane must not stretch by more than 2 centimeters when the mass is attached. So the 100 meters could stretch by at most 2 centimeters. What's the maximum mass of that can be lifted by this crane? And we'll get the value of y. So we have, in this case, again it's a case of tensile modulus. So we look at F over A, y, delta L over Li. The force is mg, and in this case we are looking for the mass. Okay, we're not looking for the weight, the maximum mass that's attached. So the mass is going to be y delta L over Li, and we have an A over G. And now we plug in the numbers and we should get the answer. So the Young's modulus is 20 into 10 to the power 10 newtons per square meter. The delta L is 2 centimeters, so 0.02 meters. The original length is 100 meters. Okay, we can add the units, Newton meter square, meter, meter. The area, okay, the diameter is 1 centimeter. So the area is pi r square, and the radius is 0.5 centimeter over 100 meter square, and that comes to 7.854 10 to the power minus 5 meters square. So we substitute that here, 7.854 10 to the power minus 5 meters square over 9.8 meters per second square. Now let's just look at the units. The meter will cancel. This meter square will cancel with this meter square. And we have newtons and meters per centimeter square. The Newton is a kilogram meters per second square, and here we have meters per second square, so we're left with a kilogram. Okay, and then when we solve this, we get the number that comes to 320.6 kilograms, which we round as 321 kilograms. Now, we take a steel ball, and the initial diameter is given. It's dropped in the ocean, falls to a depth of 10 kilometers, so that's a rather deep part of the ocean. What would be the fractional increase in the or decrease in the volume due to the pressure of the water? And we get the value of P. So the pressure at the bottom of the ocean is going to be given by rho GH plus the atmospheric pressure. So the delta P is rho GH. The density of seawater we can take as 1024 kilogram per cubic meter. The G is 9.8 meters per second square, and H is the depth of the water, which is 10 kilometers. So we multiply it with 10 to the power 3 to get it in meters, and that becomes the pressure 100.35 into 10 to the power 6 newtons per meter square. That becomes like 1000 atmospheres. Now we look at our equation. So B equals minus delta P over delta V over VI, which gives us what we're looking for. Delta V over VI is going to be delta P over B. Well, this is positive, so this is negative because delta V is negative because it's decreasing in volume, but we're just looking for the magnitude, so we will ignore the negative sign. And then the delta V by V will be the delta P, which is what we have here, and the bulk modulus is 6 into 10 to the power 10. That's newtons per meter square, and this is also newtons per meter square, so they just cancel out. And this, when we solve that, comes to 1.67 10 to the power minus 3. So that is the fractional change in volume, which can also be written as 0.167%. So there's a less than a 1% change in the volume.